Hello students, welcome to Akshara 8 Foundation. So today we are going to start in the 7th class, we are going to start the new topic, that is work, power and energy, work, power, energy. Okay. So in our daily life we can do there are many works, okay, physical works we'll do there and mental work we'll do there. So work can be classified into two types. One is the physical work and mental work. So mental work means the mind related work, all the works, say like reading, okay, and thinking, okay, and giving the speech, okay, and these are all the mental works, okay, and writing also mental work only. Then see here physical works, playing and lifting the objects from here to there. So this is a physical works there. And doing the lifting the objects and placing somewhere. So these are come to the physical works daily in our daily life we will do them. Okay, but as coming to the physics, then how can we define the work? So work, how it can be defined. So that will be see there. So first we'll see here about the work. So we are going to learn about work first. Okay. So then according to physics, then the work it is defined as, suppose any work has to be done. It is said to be done means there certain force is applied. The force has to be applied on the body, and there is some displacement of the body has to be takes place. Suppose let us consider here an object is there. So this is one object of mass m. Consider it has a mass m there. One block is there on the floor, and here a force is applied there. A pushing force is applied on the body. So if the force is applied on the body, what happens there? The body will be coming into the motion. So it will be moved from here to here, certain displacement there. Okay, it will be come up to here there. Okay, so the body will become up to here. So then, so certain force is applied and displacement is there. Then we can say there the work done. The work has taken place here there. We can say work has done there. Okay. Suppose if I apply the force on the board there, then I am applying the force, but there is no displacement. According to physics, we can say there is no work has done. Okay. So if the force is applied, there is a certain displacement of the body has to be takes place. Then only we can say the work has done there. Suppose if I hold the object like this and I am standing here, then what can write here? We are applying the force. What is the force is applied here? It is the force is applied to hold it. Okay. So then there is no displacement of the body there. Then in this case also we can write here there is no work done according to physics there. Suppose I am holding the object and moving from here there. Okay, I am moving from here to there. Okay. Then in this case also the displacement is where the displacement is in one direction and perpendicularly the force, gravitational force is acting there. So in this case also we can say there is no work has taken place, there is no work done. Okay. According to physics, so it has to be mentioned there is a work done is happened, means the force, if the displacement of the body has to be takes place in the direction of the applied force, or it is in the opposite direction of the applied force, then only we can say that the work done has there. So then W is equals to force into displacement, we can write there. Excuse me. So another force, another definition of the work, it can be known as here. See, W is equals to F into S, we can write there. W is equals to F into S. So if W is equal to F into S, then the product of force and the displacement, then we can say it is a work done. Now force is a vector quantity and here displacement is also vector quantity. Vector is nothing but the physical quantity which has both magnitude and direction. Then we can say there is the physical quantity is said to be the vector quantity there. So now here the work done will be the product of these two. There. So here we can write that it is the dot product of these two vectors. Then here W is equals to, we can write here F into S cos theta. So here now the work done can be defined as, the work is said to be done and a body when there is a the displacement taken place when the force is applied in the direction of the displacement there, or the displacement may be in the direction of the applied force, or it may be in the opposite direction of the applied force. So then, but if the force is applied on the body, there is a displacement has to be takes place there. If there is no displacement, then there is no work done there. Or the force is applied in one direction and perpendicular to that, there is a displacement will be there. So in that case also we can say that there is no work has done. Okay. So how can we say that here? Suppose here we can write here W. So W is equals to R. One more definition we can say that the work done is nothing but the force. It is the product of force and the displacement vector. It is the product of force and displacement. Is also known as the work done of a body there. Okay. Then whenever it is a dot product of the two force and displacement vector, two vectors, so it will be Fs cos theta we can write there. Okay, Fs cos theta. So now here, by using this one, we can write here when this work will be maximum and when this work will be minimum there. Okay. Suppose if theta is equals to, if theta is equal to 0 degrees, if theta is 0 degrees means the force in the direction of the applied force, the force is applying here in the same direction the displacement is there. Means both are in the same direction, then theta will be 0. Then in that case, the force will be, in that case the work done, then the work done is equals to, work done is W is equals to Fs cos 0, cos 0 value 1 there, here we will get there Fs. This is a maximum work done. So it is a maximum work done. Okay. So now if theta is here, if theta is equals to 90 degrees, if theta is equal to 90 degrees, then the work done is equals to, then the work done will be, work done is equal to 0. Why it is 0 there? So W is equals to Fs cos 90 value will be 0. So here 0 into something will get 0 only. So here the work done W will be equal to 0. W will be 0. This is a 0 work done. Okay, now third one we can write here. Third one, if theta is equals to 180 degrees, then if theta is equal to 180 degrees, the work done is equals to, the work done is W is equals to here. So Fs cos theta, we will detailedly discuss whenever we are discussing the different types of work done. Okay. So positive work done, 0 work done and negative work done. So here cos of 180 degrees, theta is 180 degrees means cos 180. Cos 180 value is 1. So we'll get here W is equals to, we'll get here minus Fs. Minus Fs will get there. This is a minimum work done there. It is a minimum work done. This is a maximum work done and the minimum work done. Maximum work done and minimum work done we can say here. So then this is a mathematical expression of the work done. Okay, and so when different angles the force is applied on the body, then how the work done, what is that work done, it is said. Now how the work done can be measured, what is the SI unit of the work done, that we are going to see now. So this you understood now? Yes. So now the SI unit of work done we are going to see here. Okay, next one. I will write here SI unit of work done. So SI unit of work, SI unit of work done. SI unit of work done. So SI unit of work done is what here? So from the formula only we will get the SI unit. This is the force into displacement. Force SI unit is what here? Newton, and the displacement unit is what there? Meter. So Newton meter will be the, so that is a Newton. Work done is Newton meter. So that is equals to what we can say there here? It is the joule. It is equals to joule. Okay. So 1 joule is equals to, we can write here Newton meter. So how can we define a joule? So 1 joule of work done. We can say here, if the force applied, 1 Newton force is applied on a body, and there is a displacement of the body is 1 meter per 1 meter, then the work done acting on the body. So work done by the body is said to be 1 joule. That is the definition of the work done, or we can say there joule, definition of the joule there. Okay, by application of 1 Newton of force on a body, the displacement undergoes 1 meter, then we can say the work done is 1 joule. That is the definition of the work done, definition of the joule. Okay, so then here we'll write here CGS unit, CGS unit. So CGS unit of work, CGS unit of work. So CGS unit of work, what can we write here? That is Newton. Newton means CGS unit is dyne. So dyne centimeter we can write there. Dyne centimeter. So this is equals to we can write here erg. That is equals to we can write here erg. So now there is a relation between this SI unit of work and the CGS unit of work. So 1 joule is equals to 10 to the power of 7 erg. 10 to the power of 7 erg. So how it will be? We have seen already in the 7th class. Now there is a Newton's and units and measurements. In units and measurement we have seen there 1 joule is equals to 10 to the power of 7 ergs. Simply this Newton meter we should convert it to dyne centimeters, so that we will get this value there. Okay. So now the dimensional formula of work, dimensional formula of work is DF means dimensional formula. Dimensional formula how we will get there? From this only Newton meter only we will get there here. So we know that again this Newton meter, what can we write here? So Newton is nothing but kg meter per second square into meter is there here. Okay. So here we will get there kg. So kg meter square per second square. Kg meter square per second square we can write here. So that dimensional formula from this only we can write there. The representation of kg. So the symbol of kg is nothing but mass. Capital M we can write here. M power 1 here meter. Meter symbol is length. So L power 2 and ST power. Second symbol is T here. T power minus 2 we can write. This is the dimensional formula of the force. So this is about the work. Mathematical expression and its work. So generally in our daily life we can see the work done is 2 types I said here. There is a mental work and the physical work. Mental work means mind related, all the works are said to be the mental works. Okay, and the physical activity by our body. So what are the work we do there? That is come to the physical work. It is a playing, running. Okay, so they all will become under the physical work there. So then according to the physics, scientifically to define the work means, so whenever the force applied on the body, there is a displacement has to be takes place there. So then then we can say the work has done by the body, or work has done on the body there. We can say that. Okay, means, or another definition we can write there. It is the product of force and displacement on the body is said to be the work. Okay, or we can also define as it is the product of it is the dot product of force and displacement. Also we can say it is a work there. So if it is a product of force and displacement, then we can write here W is equals to F bar dot S bar we can write there. F bar dot S bar means it is the dot product. So in this vectors we have learned their dot product of these two vectors is nothing but, so here we can get the scalar, the here dot product of two vectors we can write here Fs cos theta. Fs cos theta we can write there. Okay. So W is equal to Fs cos theta. Then if the theta value changes there, then the action of force will be in different angles. Okay. Means the force is acting on the body in the same direction, displacement is there means 0, and the action of force is in one direction and displacement will be in perpendicular direction, that is 90 degrees. And if the action of force is in the one direction and the displacement will be in opposite direction, then we can say the angle between them it is 180 degrees. So like that there is a maximum and minimum work done and zero work done will be there. So based on this angle of force acting on the body, there are different kinds of work are there that detailedly we'll discuss later. Okay. Now the SI unit, SI unit of work done. So SI unit of work done we'll get from the formula only. What is the formula here? So formula will be force into displacement. SI unit of forces were there Newton, and the displacement unities were there meter. So Newton meter will be there. So Newton meter, Newton is nothing but again mass into acceleration, kg meter per second square, and meter is again meter only. So we'll get here what there, kg meter square per second square will get there. That is nothing but Newton meter, that is nothing but the joule. Okay, now the joule can be defined as, if the force is applying on a body of 1 Newton, then the displacement of the body is 1 meter, then we can say the work done by the body is 1 joule. Then the work done by the body is 1 joule. That is the definition of the joule. And now CGS unit of the work. CGS unit of work is nothing but diet centimeter. Diet centimeter is nothing but, that is equal to, we can say here, erg, and the relation between SI unit of work and the CGS unit of work is 1 joule is equal to 10 to the power of 7 erg. And later we can write the dimensional formula. From this SI unit only we can write the dimensional formula, that is m power 1 L power 2 T power minus 2. So this is about the work. Okay, now we will discuss positive work done and the negative work done and the zero work done. So by using this only we can write there, and we will see the examples. Okay, so this is about the work, and types of work we will see here. Types of works. Okay, next one we are going to see here, types of work. Types of work. Okay, there are 3 kinds of work is there based on the action of force, the angle of force acting on the body. Based on that, there are 3 different kinds of forces. So work done. So first one is the positive work done. First one is the positive work done. Positive work done. Here we can add the work done. And second one we can add here negative work done. Negative work done. And third one is zero work done. Zero work done. So now we'll see one by one. Positive work done we'll see here first. Okay. So now whenever the force acting on the body, and the force is applying on the body in the direction of the applied force. In the direction of the applied force, if the body is moves there, so displacement also in the same direction. Displacement also in the same direction. Then the angle between them it is 0 degrees. Angle between them is 0 degrees. So work done W is equals to, we can write there, F into S cos theta. Okay. So W is equals to F into S cos of 0 degrees. Theta value how much there? 0 degrees. So cos 0 value. Since here cos of 0, cos 0 is equals to 1. 1 value, then here we can write W is equals to F into S 1. So therefore we will get here, that is a F into S. So W is equals to F into S will get there. This is the maximum work done. This is the maximum work done. We can say it is the positive work done. Maximum work done and positive work done. Maximum work done and positive work done. Positive work done. This is a positive work done. Means if the direction of the applied force, in the direction of the applied force, if the displacement of the bodies take place, then there is a maximum work done will be takes place. That is called the positive work done. Okay. So now next one we'll see there here negative work done there. Negative work done. So negative work done means we'll see here the negative work done now. Okay. So negative work done means suppose the force is applied in one direction. Force is applied here in downward direction, and the displacement of the body. So the displacement of the body is in opposite direction there. Okay. The force acting on the body is downward direction and the displacement is in upward direction. Then we can say here it is a negative. Now the angle between these two vectors is here 180 degrees. See here, this is a downwards and this is upward there. What is the angle here? Downward means there is a theta value will be 180 degrees. Theta value will be 180 degrees. If the theta value 180 degrees, then so work done formula F is W is equals to Fs cos theta. So Fs cos theta we can write here. Then W is equals to F into S cos of 180 degrees we can write here. Since cos 180 value is here minus 1. Cos 180 value is minus 1. That has to be remembered. Okay. So now the W is equals to here, W is equals to F into S. Cos 180 degrees minus 1, we can write here minus 1. So we'll get here minus Fs. So here this is a negative work done and it is a minimum work done. Minimum work done. That minimum work done is a negative work done. Minimum work. So this is a negative work done. That will be the negative work done. Okay. So and here we can see the many examples for this. So examples here we can write for the positive work done. Suppose if you apply the force on the body there, any object is pushed. Okay. In the case of pushing there, the body will be move in the same direction of the applied force. The displacement of the body is also in the same direction. So that are said to be the positive work dones. Let us consider the same example. A block is or a beer wall, the almirah is moved. Okay, it is pushed there. Applied force. If you apply the force, then in the applied force direction, the displacement of the almirah will be there. So in the same direction, it will be moved there. Okay. So that is example here we can take. And for this, it is an example of this negative work done there. So best example we can take there in olden days to take the water from the well. There is a wheel and axle will be there. Over the groove of the wheel, there is a rope will be there. So one end of the rope, the bucket has to be tied, and other end will be in our hand there. Okay, and it is, and it will be the rope. The bucket will be placed into the deep into the water, and while it is pulling. So in the case of pulling there, we will pull it down and the body, the bucket with water will be moves up there. So displacement will be in opposite direction and force will be in downward direction there. Okay. Even it is in the case of crane. Okay. So the force will be, tensile force will be downward direction it will be, and the displacement will be upward direction to take the body from certain depths. Okay. So these are all the example for this case, negative work done. So when the zero work done, so zero work done means here the force is applied in one direction. Okay, the force is applied in downward direction and the displacement is in upward direction. Means in right angle to it there. Right angle. There is a right angle now here. This is a 90 degrees. That means I am holding a suitcase and I am walking there. Like a person holding the suitcase and walking on the platform, then what is the force? It will be act there. There is a gravitational force will be act there whenever he is moving there, and the displacement will be in right angle to that gravitational force. So in that case, we can say there is a 90 degrees between the force and the displacement vector. Then here W is equals to Fs cos theta we can write here. Then W is equals to F into S cos of 90 degrees we can write. Okay, cos of 90 degrees. Then we can write here W is equals to Fs cos 90 value here it is 0. So since cos 90 value is 0, if the cos 90 value will be 0 here, then W is equals to Fs into 0. That will be multiplied. 0 is multiplied with something, so we'll get here 0 only. So we'll get there 0 work done. It is a 0 work done there. Okay. So in the case of object hold in the hand and it is moving there, or object is hold on the head of the person and he is moving or he is standing still there. So in that case also we can say there is if the person is standing still, there is no displacement there. If it is holding the box on his hand and he is moving, so in that case also the displacement will be right angle to it the applied force. So gravitational force will be back downward direction always. So the displacement will be in right angle. So in that case also, those are all the examples of this zero work done. Okay. So this is about the different kinds of work done. Okay. And now we'll see there here. So now we'll see here next one. So up to here it is there work done against the gravity. So work done against the gravity is one more concept is there here. So work done against gravity means here the work done. So if the body is there, that we'll see there work done against the gravity. Okay. So then We'll see that, so that we can see here in the energy topic we are going to see. Next one we are going to listen here, understand the energy, there will be get it there. Even though we'll see here the work done against the gravity. Suppose if the body is lifted from the ground to certain height there, so in that cases this work done against the gravity it will be takes place. So then what is the mathematical expression for the work done we will be seeing now. Okay. So next topic is work done against the gravity. Work done against the gravity. Against the gravity. Work done against the gravity. So work done against the gravity. Suppose here an object is there on the ground and it has a mass and weight of that will back downward direction. There is a mg, it is the w there, and it is lifted to certain height there. So F. So here h is equals to h, we can write there h. Okay. So now if it is lifted to this certain height there h, then here also the weight will be act downward direction. Then what is the force? Force acting, gravitational force is acting there, and it is lifted up, and the displacement is also it is lifted up there, but the weight is acting downward direction and the displacement is upward direction there. So here the work done we can write here force into displacement. Then force is what there here we can write here cos theta, no? Cos theta. So now force is what there this only. This is a force mg weight. So and displacement here h and cos of 180 degrees. Here what is that? This force is acting downward direction. And work done against the gravity we are saying there, and here we will apply the force like this, no? Against this gravity, this is equal. So we can write here in the same direction. Suppose if we consider the force against the gravity we have said there, means we are lifting there. So then force is acting in the same direction of the displacement. Then theta we can write here 0 degrees. If theta is 0 degrees and here cos of 0 degrees we can say, then cos 0 value will get here 1 there. So we will get here mgh. Since cos 0 degrees is equals to 1. So this is a work done against the gravity we can say. So work done against the gravity is a positive value, positive work done, and the work done by the gravity is the negative work done there. Okay, work done by the gravity is the negative work done because always the gravitational force will be at downward direction and the displacement of the body is upward direction. So the theta will be 180 degrees there, and in this case, so against the gravity we are saying there, against the gravity means with the same weight of the body we should apply upward direction there. Force is acting upward and the displacement is also same direction, then theta value will be 0 degrees. Then if you write in this formula, then we will get the work done formula. So work done against the gravity is W is equals to mgh, we can write there. Okay. So these are the, in this concept, in the synopsis, in the first synopsis, it is mentioned this only. So this is, we have completed here synopsis 1. Synopsis 1 completed, and we'll see now here concept based questions. Okay. So page number here 35, we have the concept based questions. See here, we'll see there one by one. A bucket full of water is drawn up by a person in the case of work done by the gravitational forces. It is a negative work done only, no? So here are the options are given there, negative work because the force and displacement is in opposite direction. The positive, it is not a positive work done, negative work done because the force and displacement are in the same direction. That is a wrong reason. So we can write here first option is the right one. Okay. So then we'll see their concept based questions. Concept based questions. So first one is first option only, option 1. First one is first option, and we'll see the second one, second question. So when the brakes are applied on moving vehicle, the work done by the braking forces positive, negative, and 0 work done are infinity. Okay. So if the force is applied means what there? Applied force. The force applied when the brakes are applied. So brakes are applied on the vehicle. So vehicle brakes are applied means, so opposite it is displacement. It is there is a brakes will be applied there. So in that case, the vehicle is moving upward and in opposite direction. In opposite direction. So for the rotation of the clockwise direction they will rotate. No, in anti-clockwise direction there is a force applied there. In anti-clockwise direction means motion of the body is forward direction, and the force is also in which direction it is? In opposite, in anti-clockwise direction it will be act there. Okay, it will be pressed there. Then we can say there is a negative work done we can write there. So braking force always act opposite to the motion of the body there. It is applied there. So we can write there is force is in the opposite direction to the displacement. So we can write here negative work done. So second one we can write here. So option 2. Option 2 there, okay. And third one, when a body moves in a circular path, the work done by the body is. When a body is moving in a circular path, work done by the body. Okay, if the body is moving in the circular path there, so work done by the body here. So what will happen there? So there is a angular displacement. Displacement will be 0 there. If it is moving in a one rotation, displacement will be 0. If the displacement will be 0 means, then the work done will be 0 here. So we can write here third option is 0 work done. Because if the body is moving in a circular path, so suppose if we consider the one rotation, displacement will be here 0. If the displacement will be 0 means W is equals to 0 only. Work is also 0 work done. Okay. So now next one we will see there here. Fourth one, work done by the body displaced in opposite direction of applied force. There is also negative work done. So we can see here fourth one is also negative work done. Here the option is 2. Option 2. And fifth one is given here. Fifth question is given. So a ball thrown vertically upward from the ground, retarding work done by the air resistance, which is following is the correct there. Retarding work done there. So whenever the body is thrown into the air there, so air will apply the force on the motion of the body. That will be the force will be air resistance. It is act downward direction and displacement will be opposite direction. So we can say there is a negative work done. Work done is negative during the ascent and positive during the descent there. Work done is negative. See here work done is positive during the ascent. Ascent means what there? Whenever it is throwing up there. Whenever it is throwing up there, then it will be in opposite direction to the, always opposite direction to the motion, there is a air resistance will be act there. So while it is in ascent and negative direction and during the descent. So positive is given there in ascent and during the negative. So here the second one is given here, positive during ascent and positive during descent is given there. And third one is given there, it is a negative during ascent and positive during descent it is given there. Work done is negative during ascent and negative during descent there. So in both the cases when the body is thrown there, the motion of the body it is in opposite direction to the air resistance in both the cases. So it will be, we can say it is both are negative. So we can write here fourth option. We can write there fifth one is the fourth option is right. Fourth option is right there. So 1 joule is equal to how many mega electron volts? So first one, this we have to discuss there. So one more, see here the photon energy. Photon energy will be measured in terms of, in the energy topic it will become there. That is in terms of electron volts then, electron volts. So this is energy required for an electron to accelerate it through a 1 degree, through 1 volt. Okay, by potential difference of 1 volt, then the electron is accelerated. To accelerate that, how much amount of energy is required, that is called the electron volt. So that detail we will discuss in the energy topic, there will be listen there. So now this electron volt is nothing but, we will say here a charge of an electron is 1.6 into 10 to the power of minus 19 joules. So 1 electron volt is 1.6 into 10 to the power of minus 19 joules. They are asking there, so 1 million mega electronic volts. 1 mega electron volt. Mega means here 10 to the power of 6 we can write here, and electron volt is what there? 1.6 into 10 to the power of minus 19 joules. So we write here 1. So 1 mega electron volt is equals to 1.6 into 10 to the power of minus 13 joules. Minus 13 joules we can write there. Okay. So 1 mega electron volt is 1.6 into 10 to the power of minus 13 joules we will write there. Here now the option is what here? So sixth one we will see here, sixth one it is given there. 1 joule, and they are asking there 1 joule. 1 joule, how many mega electron volts? Here we can write there 1 joule is equals to, so 1 by 1.6 into 10 to the power of minus 13 mega electronic volts. So if you write here, this is up there. If you send it up there, so how much we get there here? So 1 by 1.6 into 10 to the power of 13 will be there here. Then if we can write here, this is a 10 into, if we take from here 1, then we'll write here, so 10 to the power of 12. So here we can write there 6.25 into. So 6.25 into 10 to the power of 12 joules will get there. That is the answer is 6.25 into 10 to the power of 12. So option 1. So first one is the right answer. First one is right answer. So for this, the solution is here, this one. Okay. So sixth one is, that is the answer. Okay. So now the seventh one is there. Dimension formula of work done. Dimension formula of work done already given now. That is what there. So m power 1 and L power 2 and T power minus 2. T power minus 2. Okay. And we are going to see the next one is here, eighth one. Work done on the object does not depend upon displacement, force applied, angle between the force and displacement, initial velocity of the body. So it is not depend on the initial velocity of the body there. Okay. So it is option 4th. Eighth one is option 4. Eighth one is option 4. It does not depend on the initial velocity. Okay. So next one we will see the ninth one. In which of the case work done is not, in which case work is not done. Okay. In which case work is not done. So first one is given here, a girl swimming in a pond. And second one is given here, a windmill lifting water from a well there. A standing by holding a suitcase in his hand. Okay, standing by is holding his suitcase in his hand there. So in that case, the work done is not taking place. So sailing boat is moving in the direction of the wind. So that is the ninth one is, we can write here ninth option. So ninth one we can write here, it is the option 3. Ninth one is option 3. And there is a relation between, 10th one is given the relation between the SI rate of work done and the CGS rate of work done. So we can write here 10th one is, so 10th one we can write here, that is a 10 to the power of 7 erg. So 1 joule is equals to 10 to the power of 7 erg. This is a right answer. So here the option is 10 to the power of 7. So first option is right. So first one is right. First option is the right answer. So that is given about this concept based questions, and we will see now the exercise problems. Exercise problems, first one we will see here now. Okay. An agent moving a positively charged body towards another fixed positive charge, the work done by the agent is, Okay. So here an agent moving positively charged body towards the another fixed positive charged, the work done by the agent. So suppose, let us consider that agent is nothing but the force only. Suppose a certain force is applied on the positive charged body to move it near to the positive body there. So but there is what will happen there, but it will be opposite, no? Repulsion will be takes place there. Takes place. So both are positive charges. The positive charges will be repulsed. Like charges will be repulsed now. Positive charge and positive charge we are bringing there, and we are applying the force, but they will be try to move in opposite direction. So then we can write here, that is the negative work done only. So JEE mains here exercise problems. First one we can write here, that is the negative work done. It will be the negative work done. Okay. So exercise problems, in the exercise, the first one we can write there. So first one here we can write there, that is a negative work done. That is just 2. Option 2 is correct. That is a negative work done. Negative work. Okay. It is the negative work done. And second one is given here. A man weighing 80 kg climbs a staircase carrying a 20 kg load. The staircase has 40 steps. Each step has 25 centimeter height. If you take 10 seconds to climb, then the work done is, okay. So they're asking the work done only. So here it is not depend, the work done will depend on the, not on the, here, on the time there, okay. Time is no need to take there. Just to 40 steps, so each step has the 25 centimeter height. The total height, how much will become there? 40 into 25, will get now. So there is a, this one you will see there. Solution for second one. There are the 40 staircases are there like this. There are the 40 staircases. So each one has here 25 centimeters. Each one has 25 centimeters. Like this, there are the 40 steps are there. 40 steps are there. 40 steps. Now h is equal to what can we write there? 40 step into 25 we can write there. Okay, 25 centimeters. Then we can write how much it will be. It will be 1000 centimeters. 1000 centimeters. No, 1000 centimeters converted into meters. So we can write here, so 10 into 100 centimeters. So we can write here 10 meters, we can write now, 10 meters. 10 meters. So h is equals to what can we write there? H is equals to 10 meters. And what is the load here? So there is a load is there. The load is how much is given there? Mg is equals to is given there 20 kg load. So there is a 20 kg load is there. 20 kg load is given. Okay, 20 kg load is lifting. So lifting means, so we can write here. So F is equals to, we can write there, W is equals to mg and into h. So we can write this 20 into g value is 10, we can write there. G value what they are asking to take there? 9.8. Acceleration to gravity. G is acceleration to gravity, that is value is 9.8 meter per second square, we can write here. So we can write 9.8 into, this is a 10 meters. H is equals to 10 meters. So what can we do here? So 2 into 98. 2 into 98 into 100 we can write there. So we can write here 1960 joules. So therefore the work done will be here. W is equals to 1960 joules, we can write there. This is the answer. That is the answer, okay. So, okay, sorry, here a man weighing is climbing 80 kg man. Here and 80 kg man, he is lifting there. So 80 kg man. So here total how much will come there? Plus 80 we should write here. 80 means 100 kg will become there. So then total mass will be, so capital M we can write here mass of the man plus mass of the load. So we can write here. There is the 100 kg we can write here. If it is the 100 kg, so this one we can write here instead of this, we can write here 100. If it is the 100 there, what will happen there now? 9.8 no? 9.8 means here 90 will be there here. This will be cancelled here. This is a cancel. So we will be right here, that is 9800 there, okay. So we can write that is the 8900 joules will get there. So now the option is what? Right option is here, first option. Second one is the first option is right answer. First option is right answer, okay. First one is right. Okay, remaining problem we'll see in the next class. Understood, no children? So thank you children, have a nice day.